Let's take a look at some of the examples of Chapter 5. And so here is example 5-3. We have three people pushing the 752 kilogram boat. In part A, they're all pushing it in one direction. Okay, in part B, two of them are pushing it in one direction and the third person pushing it in the opposite direction. So go ahead and pause the video, read the problem, just like I did, okay? Write down things that you have, and then continue working the problem with me, right? So we have three people at part A, three people. So each are exerting 80.5 newtons. So 3 times 80.5, okay, which is 241.5 newtons in one direction, okay? And then the boat mass is 752 kilogram. So now we're looking for acceleration. Acceleration is what? Let's see. Sigma F is ma, right? So sigma F is ma. Sigma F is 3 times 80.5, which I already have it there, 241.5. 241.5 equals mass of the boat 752 times A. Okay, so A in this case is 241.5 over 752, which is, based on the calculation that you can see down here, is 0.321 meters per second square. Okay, so part B, two of them are pushing in the negative direction, one of them is pushing in the positive direction. So if we consider this direction to be positive and this direction to be negative, okay, kind of like that. So in this situation, what we have here is a little bit different because two of these forces will cancel out. So we have a force of plus 80 to the right from this guy right there. And then we have a negative 80 negative 80. Both of them are in the opposite direction of the plus one, so they are all negatives. Okay, and then they are equal to ma. So this negative 80 and this positive 80 will cancel out. We are left with negative 80 equals ma, which is 752 times a, and a is negative 80 over 752, which is a negative number, meaning the boat will move to the left. Okay, negative of 0.107 meters per second square. Okay, let's take a look at this one, example 5-4. So pause the video, read the problem first, and write down things that you have, and then after that, we're going to solve it together. Okay, so in this example, we have a airplane, and it has a mass of 1.75 times 10 to the power of 5 kilograms. Okay, so here is the mass. Okay, and an initial speed of 26.8 meters per second. So that's the initial speed of it. And it will slow down to slow 122 meters. So what is the magnitude of the force of the, so what is the force that is being exerted on the airplane in the negative direction of the motion, okay? So kind of stopping the plane after a while. So if you're looking at this, first of all, something that is very important to notice is that when we have sigma f equals ma, a is a vector, f is a vector. And this guy is in a scalar, okay? M does not have a direction, okay? So if it doesn't have a direction, that means whatever direction that A has, F will have the same thing, okay? So if that's the case, which you can actually see the actual picture of how it's stopping after the it ended up being the end of the airline, okay? Now, so let's take a look. First of all, let's care about A. We don't have any information about the time, so we're going to use the time-independent equation. V squared minus V initial squared is 2A delta x. And V final is 0 because it will eventually stop. V initial, it's been given to us, right? 26.8 meters per second. So 26.8 meters per second squared equals 2A, and delta x is 122 meters. 122 meters. So that means I can find A with the very simple calculations. So negative 26.8 squared over 2 times 122 will give me negative 2.94 meters per second square. So negative 2.94 meters per second square. And it means that if the airplane is moving towards the positive, so the velocity is towards the positive, acceleration is towards the negative. It is the slowing it down, okay? That's what it means. Now, sigma f equals ma. So if we have an airplane, okay, let's say that this is an airplane, it's a terrible airplane. If we have an airplane, okay, and it has a mg, which is always down. It has a normal force because it is staying on some surface, so it's a normal force, but they will always cancel out. And then it does not have any force pushing it forward towards the positive. The only force is the force of friction, or I'm just going to show it with a small f, okay? So sigma f, whatever it is equal to m, which is 1.75 times 10 to the 5, okay? 1.7575 times 10 to the 5 kilogram times A, which is negative 2.94, okay? And if we find this, it will be 5.15 times 10 to the 5. So 5.15 times 10 to the 5 newtons, okay? Exactly. Now, what does this negative mean? It means it's in a negative direction. Remember, the airplane is moving along the positive, so that means that this direction, the other direction, is negative direction, okay? So what is the magnitude of that? The magnitude of that is magnitude of negative 5.15 times 10 to the 15, which is just positive 5, 15, 10 to the 15. Or it is actually 5, not 15. So this is just 5. Regardless, what it means is that this negative is only showing us the direction. Okay, so that's what it means. Okay, let's take a look at this problem. Example 5-5. Pause the video, read the problem, write down things that you have, and then let's solve it together. All right, so we have a pitcher through a 0.15 kilogram baseball accelerating it from rest to the speed of 90 miles per hour. Estimate the force exerted by the pitcher on the ball. All right, so first thing first. There is a little bit of a problem here, and the problem is right there. It is 1990 miles per hour. We know that miles per hour is not our SI unit. Okay, so what we have to do is to get rid of that mile per hour and change it somehow to meters per second. So what we need to do is this. So we have 90 miles per hour with, well, let's slide it like that, 90 miles per hour in the form of if there 1 mile is 1.6 kilometers, okay, and 1 kilometers is 1 kilometer is 1,000 meters. So let's take a look what I have done. I have changed a mile here to meters because this kilometer and this kilometer will cancel out. One is in the denominator, the other one is the numerator. This mile and this mile will cancel out, and I am left with meters per hour. But I have to get rid of this hour as well. So I know 1 hour is 60 minutes, and 1 minute is 60 seconds. So let's take a look, see what I have done. So this minute and this minute will cancel out. This hour and this hour will cancel out. Kilometers and kilometers will cancel out. Miles and miles will cancel out. I am left with 90 times 1,000 times actually 1.6 times 1,000, okay, over, what do I have in the denominator? 60 times 60, 60 times 60, and the unit is the right unit right now, meters per second. So I am left with meters per second. Hooray! That means that I have turned my mile per hour to meters per second, and that's the number that I want, which is 40 meters per second. If you calculate that, if you put it in your calculator, you'll get 40 meters per second. Okay, so now that I have turned that, I am looking to see what the problem is asking for. I have a ball which is 0.15 kilogram, accelerating from rest. So initial speed is rest, or 0, to the final speed of 90 miles per hour, right? So we're looking to find the force, and we know that if I want to find the total force, I have to have A, because this one is M is 0.15 kilogram, A is unknown. So we have to figure out a way to find A. And I know that this problem does not give me any information about the time. So what I have to do is to write down the time independent equation here. 2A delta x. Okay, so when you're looking at this, you're looking for A. So initial speed was 0. So boom, this is 0. Now what I have is A is v squared over 2 delta x. V squared is 40 to the power of 2, because this is the final speed. 2 times delta x is 2, right? So A then is 400 meters per second. That's our A. All right, 400 meters per second squared. Now I'll get that A, and I will bring it over there. All right. So it means that our sigma f now is 0.15 times A, which is 400. Okay, that will give us 60 newtons of force acting on the ball. So 60 newtons force acting on the ball. Okay, let's take a look at a very important problem, example 5-6. And pause the video, read the question first, and then we'll come back here and solve it together. All right, so two groups of canoeists meet in the middle of a lake. After a brief visit, a person in canoe 1 pushes on canoe 2 with a force of 46 newtons to separate the canoes. So we have a force here, all right? And to separate the canoes, the mass of canoe 1 and its occupants is M150 kilograms. So here M1 is 150 kilograms. And the mass of canoe 2, M2, is 250 kilograms, okay? Now, find the acceleration the pushes gives to each canoe, and what is the separation of the canoes after 1.2 seconds of pushing. So let's take a look. So we have a constant force of 46 newtons. And so here's a little of a graph which helps us. We have a positive x direction here, we have a negative down there, and this is the direction of the push. So this guy is pushing canoe 2, so F2 is that way, and it has a reaction. For every action, there's a reaction, right? In the opposite direction, so we have F1 over here. Now, let's take a look to see if we can solve the problem. So we know that the acceleration are different, even though the force is the same. The force is 46 newtons. So force is the same, which is 46 newtons. Well, we know the accelerations are different because the masses are different. So for sigma f equals ma, it's a general formula. Okay, for 1 and for 2, it will be this different, 46. For 1, it will be in the negative direction because of this positive direction that we have chosen to be to the right, so the negative is to the left. And when we kind of see that F2 is that way, F1 is the reaction is this way. So negative, positive. Is M1 was 150 kilogram. Okay, and A is just A. I'm just going to call it A1. And M2 was 250 kilogram, and I'm going to call it A2. So A1 then is negative 46 over 150, okay? And A2 is positive 46 over 250. Okay, the book has calculated both of them for us, 0.18 and negative 0.31, okay? So negative 0.31 and plus 0.18. And these are all in meters per second square. So we know that. And then, so it has a motion. So one of them is going to the left, the other one's going to the right. And it says after how much? After 1.2 seconds of pushing, and after that, how far they're apart. So in other words, let's find x1, which is half at squared plus V0t, and V0t is 0. We know that, right? So half of A, for example, for 1 is negative 31. So negative 0.31. T squared 1.2 seconds it was, right? And x2, which is going to the positive direction, is half a t squared plus b0t. This one is also 0 because initially they were at rest. So it means half a is 0.18, t squared is 1.2 to the power 2. Okay. Now, so x1 is in that direction, in a negative direction. So that's x1. x2 is in positive direction. The time for both of them is 1.2 seconds, but the acceleration are different. And this is the general formula that we have for displacement. For each of them, I'm just writing them, okay? And this is 0. So now, what I have, if I calculate this, let's see if the book has calculated it already for us. Negative 0.22 meters. So negative 0.22 meters. And the book has also calculated the other one for us. 0.13 meters. Okay, so if I want to, so this is negative 0.22. This is 0.13. If I want to find how far they are apart, if I want to find this much, I have to add them up. This negative here, the negative means in the negative direction. Okay, that's what it means. Now, if I do that, I will have 0.13 plus 0.22, which is 0.35 meters away from one another. One of them is 0.22 in the negative direction. The other one is 0.13 in the positive direction. So that means it is 0.35 meters in the as if they are apart. Okay, so example 5-8, this is a very, very, very important example. I am going to highlight it because it's extremely important. You have seen this in a lot of physics books, or in general in a lot of physics homeworks. So I just highlighted it. Let's take a look at it. Pause the video right now. Take a look at this problem first, and write down things that you have. Once you're done with that, let's come back here and solve it together. All right, so what we have here is a box of mass M1, 10 kilogram, rests on the smooth horizontal floor in contact with a box of M2, 5 kilogram. So this is M1, 10 kilograms, this is M2, 5 kilograms. And now you push on the box 1 with a horizontal force of magnitude 30 newtons. So F here is 30 newtons, okay? What's the acceleration of the boxes? So they're moving with the same acceleration, but we want to know what it is, and what is the force of contact between the boxes. So let me write down the problem a little bit easier here. I have a box 1, M1, 10 kilogram, and I have a box 2, M2, of 5 kilograms, okay? So that's what I have here. 10 kilograms, 5 kilograms. And then I have a force of 30 newtons acting on them. I am looking for the contact force. So I'm looking for a force that is being exerted from 1 to 2. So that's what I'm looking for, okay? And I am also looking for A. These are the things to look for. So let's go back and do this problem. So we know sigma F equals MA, okay? the most important thing here is first, let's do a free body diagram. I have M1G here. I have M2G here. I have normal force N2, and I have normal force N1. We always know that the normal forces, the forces that are perpendicular to the direction of motion will always cancel out. The forces that are perpendicular to the direction of motion will always cancel out. This means that N2 is M2G and N1 is M1G. That's what it means, okay? Now, but this doesn't have anything to do with our problem. It's something that will help you to solve other types of problems. This is a good practice if you do that. So go back to our original problem here. What I have is that I have sigma F equals MA, okay? Sigma F is just F, or 30 newtons in our case, because that's the only external force or the total force being acting on the two objects. I have M, which is M1 plus M2. Why is that? Because this 30 newtons is responsible for the motion of two objects, 10 kilogram and 5 kilogram, okay? And then I have A here. So which means that M1 plus M2, 10 plus 5 is 15 times A, and A is 30 over 15, which is 2 meters per second square. All right, so if you do that, this one is checked. Now let's take a look at F of 1 to 2. We know that, again, sigma F is MA. Sigma F, or the total force that 1 is exerting on 2, is just F1 to 2, or F12. M, how many masses this force is responsible to move? There's only one force and one mass in front of it, that this force, which is F12, is responsible for it. So this F12 is only responsible for the motion of this mass that is in front of it, which is only 5 kilogram. So we have M2A, right? So F12 is M2, which is 5 kilogram. Again, this F12 is only pushing on the 5 kilogram object here. And we have A, which is 2 meters per second. This will give us the 10 Newton of force between the two boxes as the contact force. Okay, a very common problem or example 5-9. Let's take a look at this problem first. So we have two forces acting on a cooler, F1 and F2. F1 magnitude is given to us, okay? So F1 is being F1 with a magnitude of 166 newtons, 166 newtons, okay? An angle of 47.4 above the horizontal, and the total weight here, if we weigh this, or if the weight here is 192 newtons, so 192 newtons down, and F2 is being applied in the angle of 36.1 degrees above the horizontal, as you can see here, but we don't know what F2 is. Find the magnitude of the force F2 that produced a net force of the cooler that is straight upward, meaning that a net force will be up. So that means anything that you have along the x direction will cancel out. So what I have here, in other words, I have a box, okay, kind of like that, or a cooler, if you want to call it. And then I have my origins being this way and that way. So I have my x here, and I have my y here, okay? Now I have other forces here as well. I have a force of F2. I have a force of F1, and I have a force due to gravity, which we already know what it is. It's been given to us. So I know that this is F2. This is 36.1 degrees. This is F1, and it is given one more time. 166, 166. This is the W due to gravity, which is just mg, or what is it, 199 newtons? Is that what it is? Take a look. 192, and the angle is 47.4. So 192, okay. 192, and the angle is, this angle is 47.4 degrees. Okay, and we want to look for the motion that is along the y direction. So that means anything along the x direction should cancel out. So the x component of F2 and the x component of F1 should cancel out along the x direction. In other words, F2 cosine of 36.1, which is this guy, F2x, okay, which is F2 cosine of 36.1, should cancel out this force, which is F1 cosine of 47.4 degrees. They should cancel out. One of them is along the positive direction, the other one is along the negative direction, and that means that they will cancel out. So their magnitude should be the same. So F2 cosine 36.1 magnitude-wise should be equal to F1 cosine of 47.4 degrees. Okay. Now let's substitute some numbers here. I don't have F2. That's okay. Okay, but I can solve for it. It is F1 cosine of 47.4 degrees over cosine of 36.1 degrees. So in other words, F2 is F1, which is 166 newtons, times cosine of 47.4 over cosine of 36.1 degrees. Okay, so that is whatever it is, just put it in your calculator, whatever it is, this will be your F2. Now, if you're looking at part B of the problem, it says determine the net force acting on the cooler, giving the fact, or giving that F2 has the magnitude determined in part A. So we know that these two will cancel out. So now what we need to do is to care for the y direction. So in y direction, okay, what we have is we have negative W, which is mg, or, you know, let's call it W or mg along the negative y, okay? We have F2 sine of 36.1, which is along the y, positive y direction. And we have F1 sine of 47.7 or 47.4, which is along, again, the positive y direction. So we have these two as well. We know what the F2 is. Let's actually take a look to see if the problem has, so we know F2 is 139. So thank God the book has already calculated for us 139 newtons. So I'm just going to use that. So 139 sine of 36.1 degrees, 166 sine of 47.4 degrees. And if you want to take a look at it, they are actually right here. So both of them are right here. So this is F2 sine of 36.1, and let's use this color. And this is F1 sine of 47.4 degrees. So if you do that, you have two forces along the y direction, positive y, and two forces along the negative direction. You have to add them up to find the total y. So I have 139 sine of 36.1 degrees plus 166 sine of 47.4 degrees minus 192 due to gravity. So this is the total force along the y direction. Whatever it is, if it's negative, then the total force is along the negative direction. If it's positive, then the total force is along the positive direction. Whatever it is, calculate it. I think the book has already done that, and it's 11.9 newtons. So it is 11.9 newtons, and it's positive, meaning that it is along the positive direction, right? Okay, let's take a look at this problem. There are more examples in the book. I am just giving you an idea of how to solve these problems. There are many more. So let's take a look at this last problem, and then you can work on other problems. And if you have any questions, you can comment below the video, or you can always contact us. So we'll be happy to answer your questions. So example 5.15, go ahead and pause the video right now. Read the problem first, write down things that you have, and then come back, we'll solve it together. Okay, so a child of mass m rides in the toboggan, if I'm pronouncing it right, down a slick ice-covered hill inclined at an angle of theta, so that's the angle right there, theta, with respect to the horizontal. What is the acceleration of the child? That's part A. And part B is, what is the normal force exerted on the child by the toboggan? So let's take a look. First thing first, we have to write down what we have. So we don't have that theta. All we know is that there is a child sliding down the hill, and has a mass m, okay? And so what we know is that it looks like something like this, as if I have a box here, okay, kind of like this. So what I have here is kind of looking like that. So in other words, what we have is a m here, and then this is theta, okay? So we have, let's see, what forces do we have? We have mg towards the Earth's center, and then we have a normal force of n, or f of n, upward. Remember, the normal force to the surface. Our surface is inclined, so that's why our normal force is also inclined. Okay, and then this is the direction of motion. So in other words, I have to write down, or kind of show, that this is positive x direction, this is positive y direction, okay? So this is positive x, and this is positive y. So remember, if there are forces here that are not along the x or along the y, you have to break them down to their components. In other words, this mg should be broken apart to the components, okay? So we have mg cosine theta, and we have mg sine theta, okay? Remember, if you're going downhill, the force that is pushing you down is always mg sine theta. Just have that in your mind. And the force that is pressing you to the ground is mg cosine. You don't have to drive these in the middle of the exam, or or if you're solving a problem, just memorize them, okay? The downward is always mg sine theta, and that's the theta that we're talking about. It is this exact same as this one. This is also theta, okay? So that was rule number one. Rule number two was always that the forces perpendicular to the motion, forces that are perpendicular to the motion with an angle of 90 degrees, they will always cancel out. In other words, your normal force will always cancel out mg cosine theta. So the only force that's acting on the object is, the only force then is mg sine theta. So now let's write down the Newton's second law. Sigma F equals ma. So what is sigma F? N and mg cosine, they've canceled out. See, I'm not using mg anymore because I have broken that apart to their components. I have decomposed it. Okay, so I have mg sine and mg cosine. So I'm not using mg anymore. So mg cosine and n will always cancel out. Boom, boom, gone. The only force left is mg sine. So mg sine theta is the total force now, equals ma. This a and this a will cancel out. G sine theta is a. So depending on, and we know what G is 9.81 meters per second square, right? So depending on the sine theta with this angle, you can find the acceleration, okay? So G sine theta. Now the part B is asking, what is the normal force exerted on the child by the toboggan? So as you know, as we've talked about it, all the normal forces are canceling out. So all the normal forces will cancel out, which means that normal force is mg cosine theta. Okay, so that's what it means. You have m, you have g, you have theta, so you can find mg cosine theta as your final answer. Okay, and it is along the y direction, as you can see, along the positive y direction.